how to show the reliability of a single item in the context of a validation study. If you develop a new measurement instrument, one thing you have to show as part of your validation efforts is its reliability. However, with single items, that's quite problematic. In this tutorial, I'll be showing you a couple of possible options you have to estimate the reliability of a single item, that is a measurement instrument with only one question. First, why should you even use single items? Then some possible ways to assess the reliability of single items, and then how to estimate the reliability of single items if in addition to that you have a longer scale for the same construct. So why should you even use single items? First, they reduce the respondent burden. That can be especially important if you have a lot of constructs you want to ask about, or in something like a diary study where you repeatedly ask the respondents about the topic. Then longer scales often can lead to mindless response behavior, because you win nothing if you have 10 items and the persons always answer the same to all 10 items. One item that captures the essence of the construct you want to measure may lead the respondents to think more deeply about that. Often they can have high validity. For more information about that, see the doctoral dissertation by Zhang, 2020. You can find the full reference information in the video description. How can you assess the reliability of a single item? What you can't do is using internal consistency. So things like Chromebox Alpha or McDonald's Omega, for those you need more than one item. In principle, you could use retest reliability. That is, letting the same participants answer this item on different occasions and then comparing the results. But there are two limitations to this approach. First, from a practical perspective, it's much more effort to get participants to answer your questions on different occasions. From a theoretical perspective, the problem can be that you can use retest reliability only for stable constructs, so things like traits. But for transient states, that's not possible, because for a state that can fluctuate between time points, it doesn't make sense to expect that the person will give the same answer at different time points. Often, the best way to assess the reliability of a single item is by not assessing it, or rather by assessing it indirectly, using the validity. Because you can only get high validity with high reliability. If you show that your single item has a high validity, that is, for instance, that it shows a high correlation with some external measure it should predict, then indirectly you have shown high reliability as well. You can see this in this formula about attenuation correction. Here we have the true correlation between two measures. Here the square roots of the reliabilities of those measures. And here is the correlation you actually measure. And if you, as part of your validation efforts, show a high correlation, then necessarily the reliabilities of those two measures can't be low, because that would reduce this correlation. So often, showing validity is the best way to show the reliability of a single item. If you're planning your validation study, there is something else you could and probably should do. If you want to develop a single item, include, in addition to that, a longer scale, that is more than one item, measuring the same construct. Because if you do that, if you have a single item and a scale measuring the same construct, then there are different ways to calculate the reliability of the single item. And I'll show you two of those. The first is using factor analysis. In factor analysis, the total variance of an item is the sum of its communality, its specificity, and its unreliability. Communality is what the different items in the factor analysis have in common, the common variance. Specificity is the systematic variance of this specific item. And unreliability is simply error variance. And we can use this formula to estimate the reliability, or at least a lower bound of the reliability. Because down here, this is unreliability. From that follows that those two taken together are the reliability of the item. The communality plus the specificity. But if you run an exploratory factor analysis, you at least get an estimate for the communality as part of the output. So the communality in a factor analysis is a lower bound for the reliability. So you run an exploratory factor analysis with your single item and the items of the scale measuring the same construct and extract only one factor. And then you take the communality of this single item as a result of the factor analysis. Here, just a simple example with SPSS, 5 items of the scale and the single item measuring the same construct. In the column extraction, you can find the communality of that item. So here we have a communality for the single item as part of this factor analysis of 0.70. This is the lower bound of the reliability of the single item. And you could report this. Here's a summary of this process. Run an EFA with the scale items in the single item, extract only a one-factor solution, and take the communality of the single item in this EFA as a lower bound of its reliability. There's a second way to estimate the reliability of a single item if you have included a scale measuring the same construct, that is, using the attenuation correction, this formula I showed you earlier. We can use this formula to calculate the reliability of a single item. Here I've changed the names to x1 and x2 instead of x and y, representing that both measure the same construct. So it's not the correlation between two different constructs, but between two different measures of the same construct. Let's say x1 is the scale and x2 is the single item. Here is the theoretical correlation between x1 and x2, that is, the theoretical correlation between the scale and the single item. And since both the scale and the single item measure the same thing, this theoretical correlation should be 1, which simplifies the formula here. If you find the formulas hard to follow, later on you will get a specific example with numbers how to calculate the reliability using this principle. So now here we have this formula and we are interested in this, Rx2x2, because that is the reliability of the single item. And we can simply solve this formula to get this. That is dividing by this and then squaring the result. This would be the formula to calculate the reliability of the single item. The squared correlation between the single item and the scale divided by the reliability of the scale. And for a scale with a couple of items, it's easy to calculate the reliability. Concrete example. Let's say we have a correlation between the scale and the single item of 0.75. And for this scale, we have a reliability of 0.85. Then we simply plug this into the formula, the squared of the correlation between both divided by the reliability of the scale. Here we would have an estimate of the reliability of the single item of 0.662. One thing to keep in mind, in general, it is better to use McDonald's omega than Cronbach's alpha as an estimate for the reliability of the longer scale in this calculation. If you use Cronbach's alpha, you could overestimate in the end the reliability of your single item. There are other methods you could use. For that, see the dissertation by Zhang, 2020. But what can you do if all that is not possible? If you have already acquired your data without any variable to show validity and without including additional items of a scale measuring the same thing as your single item, what can you do then? Basically, you can only be honest about it. Hopefully, if you haven't developed the single item yourself, there is some validation study of those who developed that, so you could report their reliability in your measurement section and write that you couldn't calculate the reliability for your sample because it's a single item and you have only one measurement occasion. So there is no formula to calculate the reliability then. And possibly report that as a limitation in the discussion section of your paper or your thesis. That's it for reliability of single items. Thanks for watching and see you in the next video.